Very good evening to all. So myself Dr. Satyam Gupta from Avaya Government College for Women, Karaikal. I have done my PhD from Raman Research Institute. My thesis title is Synthesis and Characterization of some non-conventional viscotic liquid crystals. So my background is chemistry. So, so today my presentation, topic of my presentation is liquid crystals and nanomaterials. So this is the plan of my presentation today. So first we'll be discussing definition, classification and various molecular arrangements which occur in liquid crystalline phases. Then we'll go to definition and importance of nanoparticles. Finally, we'll be discussing some recent examples from research papers in which interaction between liquid crystals and nanomaterials has been investigated. What are liquid crystals? As we all know that there are three states of matter, that is solid, liquid and gas. These are there are certain materials which on heating before going to complete isotropic liquid phase, they go to one intermediate opaque phase or state which is having combination of order and mobility. This phase is called liquid crystalline phase and these materials are called liquid crystalline materials. In this phase, the material shares applicable property of solid, that is directional property, and applicable property of liquid, which is mobility. Due to this property of these materials, these materials are phase are distinctly different from either of traditional states. Molecular moiety, which is responsible for liquid crystalline phase formation, is called lysogen. Liquid crystalline materials can be classified in various ways. On the basis of molar mass, we can have low molar mass and high molar mass liquid crystals. On the basis of temperature and solvent property, we can have thermotropic and lyotropic liquid crystals. On the basis of mesogen or mesogenic moiety, which is responsible for liquid crystalline phase formation, on the basis of shape and size of those moiety, we can have rod-like or calamatic, disc-like or discotic, and banana or bent core liquid crystalline materials. These are arrangement of molecules or mesogens in liquid crystalline phases exhibited by calamatic or rod-shaped mesogens. The first one at extreme left is synaptic phase, which is in which mesogens are arranged in layers. The second one is the structure of nematic phase, where mesogens are not having any positional order. It, it means there is no layer, but they will be oriented approximately in one direction. The third structure, that is scholastic nematic, in which within a layer molecule will be having some orientational order, but on going from one layer to other layer, overall orientation of molecules keeps changing or twisting. So the arrangement on the bottom is blue phase, in which two cholesteric type of arrangement coexist in direction perpendicular to each other. So disk-like molecules or discotic molecules are having tendency to stack one upon each other to form columns like a pile of coin due to pi-pi stacking, pi-pi interaction and pi-pi stacking. After forming column, these columns can arrange in various lattices which are shown here. Hexagonal and columnar are most common. So on virtue of having one-dimensional charge migration, these type of materials are having application in various electronic devices such as solar cell, TFT, LED, etc. So what are nanomaterials? Nanomaterials are substances or material in which particles are having at least one dimension less than 100 nanometer. On decreasing particle size in nanometer range, many physical properties of materials change and becomes distinctly different from bulk material. Within a nanometer range also, properties of these materials is affected by their shape and size. On the basis of dimensionality, we can have 0-dimensional, 1-dimensional and 2-dimensional and 3-dimensional nanomaterials. In 0-dimensional nanomaterials, all the three dimensions of particles are having size less than 100 nanometer. Similarly, we can have 1-dimensional, 2-dimensional and 3-dimensional nanomaterials. Different size of nanomaterials have different type of activity. Next is, what is nanoscience and nanotechnology? The branch of science which deals with study of depression and structure property relationship of nanomaterials is called nanoscience, and combination of two or more concepts of nanosciences which can be applied to improve or develop new technology is called nanotechnology. Our first example of nanomaterials in liquid crystals is fullerene as guest molecule in star-shaped oligophenylene vinylene mesogen. This star-shaped OPV is responsible for dyskotic mesophase formation. In this work, fullerene molecule is covalently linked to one arm of star-shaped OPV. It is observed that on attaching one fullerene molecule, stability of mesophase increased by more than 70 degrees Celsius. As can be seen from the small angle X-ray diffraction, presence of three additional strong peaks indicates high level of order in columnar mesophase. In this example, multi-walled carbon nanotubes were dispersed into matrix of room temperature pneumatic liquid crystals at 0.1 weight, 0.01 weight% and 0.02 weight%. As can be seen in two figures on the right side, relative permittivity relative permittivity has higher value in case of 0.01 weight% and 0.02 weight% doped sample. It was also found that dispersion of carbon nanotubes in pneumatic matrix decreases threshold voltage. Threshold voltage. These properties make them useful uh, candidate in designing energy efficient electro-optical devices with faster response time. In this example, zero-dimensional fullerene, one-dimensional nanotube, and two-dimensional graphene were mixed with biphenyl-based calamatic mesogen, which is shown in the figure, at various weight percentage. As can be seen from the four phase diagram shown below. The stability of blue phase increases on increasing weight percentage of nanomaterials. In some cases, it leads to the complete vanishing of cholesteric phase to maximize the blue phase temperature range. In this example, hexacyanographene-based calamatic liquid crystals were doped with graphene oxides at various concentrations up to 2% of graphene oxide. As can be seen from the figure on the left side, electrical properties of graphene oxide doped sample were in higher as compared to the pure sample. It was also observed that thermal stability of sample was increased with graphene oxide concentration. In this example, graphene oxide nanoparticles were dispersed in pneumatic liquid crystals. Charge capacitance versus voltage graph shows that charge capacitance was noticeably increased on doping with graphene oxide. Threshold voltage and display elastic constants also increased on increasing graphene oxide concentration. This can be attributed to a strong planar anchoring of pneumatic liquid crystals molecules on the surface of graphene oxide sheets, which remains parallel with respect to the substrate plane as an electric field is applied. So, strong host-guest interaction between graphene oxide and liquid crystalline phase were proved spectroscopically. This is the example in which all inorganic perovskite quantum dots has been treated with blue phase liquid crystals. So as can be seen from the figures on the left hand side and right hand side both cases. So what they have done. So they have treated cesium, lead, bromine, perovskite quantum dots with blue phase liquid crystals, and they have found out that in all the cases, liquid crystalline phase range is increasing. Okay, as can be seen from this figure. So, so this type of systems, since quantum dots are having photochromic characteristic, so this type of systems can be useful in liquid crystal display, optical sensors, laser host, and fluorescence displays. So in summary, we have discussed classification of liquid crystals and also about arrangement of mesogenic molecules in liquid crystalline phases. We also discussed definition and significance of nanomaterial, nanoscience, and nanotechnology. We also talked about interaction of discotic calamatic liquid crystalline materials with various nanomaterials reported in some recent literatures. Thank you very much for your kind attention.